Hello, everyone. Welcome to the Spotlight stage. Thank you guys for taking time for this next presentation. I'm Mark Demers, the Spotlight stage host. I'm glad you're here with us. Show of hands, who's using synthetic data or wants to use synthetic data? Well, then this presentation is for you. So I'm not going to waste time. I'm turning it over to Brett Wijak and to Sundaresh from SAS. They're going to talk to you about SAS Data Maker. I'm going to come around with this handheld and I'm going to scan your badges and try to not be annoying. So,
all right, thank you, Mark. And welcome everyone to our overview of how synthetic data, with especially generated in a really easy and convenient manner with SAS Data Maker, can make a difference for you and your organization in your AI development efforts. I was really excited to see those hands go up. At least, that was a good handful of people there. Some of the SAS people mixed in, so maybe that didn't count. But it's a whole new world with AI these days. We're all living it. It's evolving really fast. And let me pause for a second and just say, when I use the term AI, I am yielding to kind of the mainstream use of the AI term. I'm including all sorts of all the analytics under the full umbrella there. And when we talk about AI, we know it all starts with data. Having good and sufficient data. And so what's the problem? We live in a data-rich world, right? We have an abundance of data. We're flooded with data. The fact is there's still a lot of challenges with accessing and using data sufficiently, and I'll get to those in a second. When we talk with our customers about the concept of synthetic data and the potential that it has to bring value to their efforts, they're really intrigued, and hopefully when you were introduced to this morning, possibly for the first time in our presentations on main stage there, it started you thinking about, all right, should I be taking advantage of this? How could I use this? Because there really is a lot of value to it. And when we talk about synthetic data with our customers, we hear kind of three main positions on it. The first is really about the potential it has for just opening up access to data and sharing data across the enterprise. Obviously, there's a lot of privacy issues and protections on data and regulations to comply with that kind of keep a lot of that data locked away from people that really could make use of it in their efforts. And Harry talked a lot about privacy this morning. And all the issues around that, and that's very important. So that's one aspect of it. Just having some representation of real data in a synthetic form that is allowed to be used in all of your AI efforts is very valuable. The second position we hear a lot is about the potential to use synthetic data to test applications and solutions that these organizations have developed, ensure that they are robust, be able to create new scenarios and potentially rare events that they just don't have real data for, to ensure that their products, their processes, the decisions made from all of their AI efforts are robust and behave as expected, and do so in a way without harming real people in the process, and do it in a cost-effective manner. So sort of some of that downstream use of synthetic data is really intriguing to our customers. And then the third area we hear a lot is really in just the AI development phase itself, that middle phase of the AI lifecycle, to kind of unlock some opportunities to explore different approaches to their products and their processes and the models that they develop, to innovate, to be more productive in that phase. And so a lot of compelling reasons to kind of turn to synthetic data, and which is why we're really excited to be providing this new offering, SAS Data Maker, for this. Now, Sundaresh, when you talk to customers about synthetic data, or you're in a customer advisory role, you're with customers all the time, when you talk to them, what's kind of their first reaction to all of this?
Brett, while customers relate very easily to concepts of privacy, protection, and testing scenarios, they are unsure about how synthetic data helps model development. For example, the other day we talked to a customer. After listening to us, she still made a comment on the lines of, but this is still made up data. So that notion of fakeness leads to customers being a little unsure about how to use synthetic data in model development directly. But really, enlightened organizations view things a little differently. Let's consider a scenario, an example, to see just how. Imagine that I'm a data scientist at a bank helping it make better decisions. Some of these decisions involve helping determine whom to approve or decline for a loan. A loan decisioning model poses challenges. Applicants come from a variety of risk profiles, and further, macroeconomic changes and what we term as portfolio shifts, they affect outcomes. So what this means is that if I continue to use historical original data alone, very soon my data ceases to be relevant for today's scenario. It ceases to be relevant for future scenarios and dynamics, and models are not as accurate as before. In short, I'll have to wait until I get enough usable data to obtain a relevant model. Now note also that model data might contain bias. This bias could be due to multiple reasons: historical reasons, systemic exclusions, participation rates. We won't get into the reasons why bias occurs in original data, but it's important to be aware of the same and account for the same, because bias in data affects machine learning outcomes, where we measure bias through performance bias and prediction bias. The net result is I make unsure predictions, and unsure predictions lead to suboptimal loss prevention outcomes. That's not a very nice situation for my bank to be in, right?
No, absolutely not. And to be honest, this is precisely the type of situation that synthetic data can really step in and help. And there's you talked about, in this case, some insufficiency, some deficiency in your model for some reason, and one of the first places to look is the data that's feeding your modeling process. And there's a few different approaches to take on this. One is just to kind of look at it purely from a data volume perspective. More data, that can potentially, it won't always help, but it can potentially fill in some of the gaps and discover some of the nonlinearities in the behaviors of the parameters and the relationships across the parameters. So sometimes just having more data can help. The other two positions are really around a more focused approach on the data that you're providing into the process. Being able to generate data on a conditional basis and focus maybe on a certain segment that is underrepresented and enrich that part of the data more. Or from an outcome perspective, if there are rare events, it's very likely that it's difficult for the model to capture some of the behavior and relationships of inputs to the model to the output in the case of rare events. So having more rare events and balancing the outcomes in the sense of the data that you're feeding the AI is very important. So we're going to start here with the simple case of, all right, let's just try generating more data and feed that into the process. And so you saw a good demonstration from Harry on main stage this morning. This will be kind of a quick run through as well. We're starting with some loan data. Again, this was a simple single table. Harry showed that we do support multi-table situations, which are very common, and uncovering the referential integrity across that and maintaining, supporting sequential data, time series-based data, getting a good view of the columns and all of the profile of these columns and the metadata around that, understanding the semantic types so we know how to generate data for those columns in a very representative manner. So Just kind of doing a quick check here, and you can adjust those as needed. And then as far as the training goes, a handful of different algorithms. In this case, we've got a pre-production version with a few algorithms in it. We're continuing to expand that out, setting different options here, including the differential privacy level that you want baked into the training and generation process, and then setting which metrics you want to be able to use to evaluate that. So I've trained a number of different models here. So it's nice that I can kind of work through an experiment and historically try different settings there. And once I kind of hone in on one that I feel is good, I can look at the different metrics for those and assess these in terms of things like distributions. Does the distribution of the synthetic data look like it follows the distribution of the real data? We're looking for a lot of purple here, which is the overlap between those. And just kind of doing some sanity check across those from a visual perspective. And then, of course, relationships among the columns. We want to make sure we're preserving the correlation, or in this case, the mutual information across those columns to ensure that's properly represented. And then when I'm satisfied with my generator, I can now use it over and over again to generate more data simply by specifying the destination, where I want the generated data to go, and the output format, and then I can specify the magnitude or volume of data that I want generated. So I've gone ahead and done that for 2x, 3x, 4, 5x, including 10x, and I can kind of, again, do a sanity check on the generated data, make sure that it looks okay from a sample perspective and the distributions. Pass that back to my data scientists to now start using in the development process and explore and see the impact of it.
Great. So here's what I did with the data you gave me. For me, a holdout data set, which I extracted from original data in the beginning, that's the gold standard against which I evaluate all results. I use SAS to train a variety of models against the many data sets that you gave me. SAS really helps me here due to its distributed processing, ability to provide multiple analytical methods, and guided templated modeling approach. I take care not to give any preferential treatment to one data set over the other. Therefore, irrespective of whether it's synthetic data or original data, the same modeling experiments, the same model parameters, I let the data dictate the results. And here are the results. Let's first consider results based on their own test data sets. What you would notice is that synthetic data of many volumes consistently gives me better separation power compared to original data. For example, for synthetic data sets, I get a KS statistic, that's a measure of discriminatory power, in the region of 0.82 and above, compared to 0.72 for the original data set. This is true even for synthetic data of the exact same volume as the original data set. This is good result, but note, Brett, this is not an axiomatic finding. It's an empirical finding. The fact that we got good results in this experiment does not ensure that we will always continue to get the same type of results. It requires a whole lot of more experimentation. But the good news is, one, I get more robust results because I can test my models on a larger volume of data. Number two, I get smoother distributions because that's how synthetic data algorithms work. This helps me in downstream activities like calibrating data sets or creating scorecards. And three, I am facilitated in getting approval for my models because no one can doubt that low data volumes affect the model results. Synthetic data offers me a way to establish the consistency and robustness of results. However, let's not get carried away. Remember, I told you about the holdout data set. That's the gold standard. When I look at results on the holdout data set, I find that the consolidated model, which is an append of synthetic and original data sets, that proves to be the best performing model for me. Why? Because synthetic data papers over the rough edges that you find in original data, and therefore helps me get better modeling results and helps me make better decisions. Okay, this is how great more data helps me, but what can I do about my bias problem? Perhaps you give me a balanced data set or something?
Right, right. So again, talk about data volume, looking for improvement in accuracy. From a balancing perspective, there's a few different approaches that we can use Data Maker for. We can initially subset our real data down to the data that we're really focused on and want to generate more of, feed that into Data Maker to train a generative model that can then generate data that is specifically for that segment, that focus segment there. That's one approach. The other approach is to just feed all of the data in and let it generate a model across the whole spectrum of the space, and then subset that by filtering afterwards. Now, in some cases, that's really your only opportunity, because you may have very minimal amount of data of the segment that you're wanting to focus on. So generating it to capture the full relationships across the full space and then subsetting afterwards is often a very good approach. And we're working on baking some of that conditional generation capability into Data Maker very soon. So I've done that and passed a more focused set back to Sundaresh to see how that impacts the results.
Great. So you've given me two data sets now. The gender balanced data set gives me an equal proportion of males to females. The gender and default balanced data set not only gives me equal male to female ratio, but also defaulters to non-defaulters in the share of 50-50. This is good because if you had given me undersampled data sets, if you'd used undersampling, a conventional technique, I would have thrown these data sets out, because the amount of filters you have to apply on data to get data of such proportions takes a long time and leads to very less data coming out of the process. But these two data sets help me because gender balanced data set helps me assess for realistic scenarios. That's how my data is in real life. The gender and default balanced data set helps me get better separation power. So I ran the same experiments as before, and what I found was that we did not experience a significant reduction in bias. But to be fair, I didn't expect that. Bias is not indicated in just one variable alone. It's just signaled by one variable like gender. But what happens is that we might have addressed bias to a certain extent by just balancing the data set, taking care of the bias that's due to poor participation rates in the past. But there is systemic bias, inherent bias, which is part of other data columns in the data set as well. So just balancing the data is not enough, but it's a good first step because it helps me quantify the bias and helps me carry out activities like bias mitigation and algorithmic treatment down the line to take care of inherent bias in the data. You can pass by the Trustworthy AI booth to learn more about bias mitigation, but what I want to convey is that balancing the data is just the first step before bias mitigation.
Yeah, absolutely. I think that's a fair point, and I think it's important for you to understand here. We're not here to say that synthetic data is the silver bullet, the magic wand, the unicorns and rainbows that Brian threw up on the screen this morning. But it can help, and it can really allow for this sort of exploration. You saw what it did for my data scientists here to try a lot of different models and see the impact of enriching data, whether it be by adding more to fill in the space or to balance the data out more effectively. And so hopefully this just starts you thinking about trying to use synthetic data as opposed to trying to capture more real data in your process and the value that it can bring. We're excited to kick off a private preview of Data Maker coming up, and if so, we encourage you to stop by the booth if you're interested in that, or if you just want to talk through more about synthetic data and Data Maker and the value it can bring to you and your organization. Thanks.
Thanks, Enrich and Brett. That was awesome. Speaking of data, so use your apps, give us feedback on the presentation, and we're going to take a very short break. Please don't go anywhere if you don't have to, because the next presentation starts at 11:45.